Right, so let's have a look at question 5. We've got 8 marks for doing integration question, where it looks like we're going to have some sort of recurrent solution from the integral, so we're going to be using integration by parts. In general, for a further maths exam, I would definitely recommend having your formula booklet open, because you might find that some of the integrals might seem quite difficult. You can find the information right here. So we're going to integrate powers of cosec, and we've given the recurrent solution here. Now, so to always look out for in this correlation is think about how we're going to want to split up this integral. Now, a good way to look at it is to look at this term. So if we integration by parts, what we've got there, we've got u and we've got v. So one of the things is differentiated, one of the things is integrated. The fact that I've got cosec to the n minus 2 suggests to me that we'll split it up as cosec squared and cosec to the n minus 2. So let's find out for that. That might not be the correct substitution, in which case we'll have to rethink it. So let's say we're gonna rewrite the integral. So I'm gonna rewrite in as the integral of cosec the n minus 2 of x times cosec squared of x. So let's say we're gonna differentiate the cosec to the n minus 2. Then we will be we'll therefore have dv dx is cosec squared. And if I want to find du by dx, so I need to differentiate, that's going to be chain rule. So I'm going to have n minus 2 cosec to the n minus 3 of x times derivative of cosec. Now, as I say, you could spend a while doing quotient rule and differentiating it, see if there's a formula with a formula booklet. So we've got it there, derivative of cosec. We've got k equals 1 is going to be minus cosec cot. So that's times minus cosec of x times cot of x. And v, we need to integrate cosec squared. It's a useful one to know, but you are actually slightly, you might look at integration and think, I'm not given the integral cosec squared. Look at your differentiation column though. If cot differentiates to minus cosec squared, then the integral of minus cosec squared is cot. So the integral of cosec squared is going to be minus cot. Okay, so as I say, if you're not got that formula, look at straight open and not thinking about that, this question will be quite challenging for you. So good exam technique to do. Right, now we need to actually apply our integration by parts formula. So we've got uv. So I've got minus cosec to the n minus 2 of x times cot of x, which is looking decent because that's the numerator of this thing. And then we need to minus the integral of all this other stuff going together. So I've got n minus 2. Cosec here is to the power of minus 2, so I've got another cosec there. And then I've got cot times cot, so we've got cot squared. And then let me think about the minus sign. This thing's a minus, this thing's a minus, times to get to be a plus. However, I've got a minus in the integral, so this is correct. Now, this here is looking very much like in minus 2, apart from this cot squared. So let's see if we can write cot squared in terms of cosec squared. There's probably going to be a trig identity. I don't remember. Imagine from a sine squared theta plus cos squared theta is always 1. So if I want cots, I need to divide by sine squared. So I'm going to have 1 plus cot squared is equal to cosec squared. So cot squared is going to be 1 minus. Alright, cosec squared minus 1. So I can rewrite this integral. I've got minus cosec n minus 2 of x cot x minus, I'm going to pull out the n minus 2. and then I'm integrating cosec to the n minus 2 now times cosec squared minus 1. So I've got minus cosec to the n minus 2 of x cot x. Now if we're to expand this, I've got minus n minus 2. You can probably do this next thing quite quickly, but I'm just going to make a point of it a bit slowly. So cosec, that's going to be cosec to the n dx minus n minus 2 integral cosec n minus 2 of x dx. And now we can kind of rewrite this thing. So this whole thing was equal to in. I just applied an irrational parts to it. So we've got minus cosec to the n minus 2 of x cot x minus n minus 2, that's in right there, minus n minus 2, that's in minus 2 right there. So if I add this to both sides, so 1 plus n minus 2 is n minus 1. So I'm going to have n minus 1 lots of in is equal to minus cosec n minus 2 of x cot of x minus n minus 2 in. So in other words, in is going to be minus cosec to the n minus 2 of x cot x divided by n minus 1 minus n minus 2 over n minus 1 in. Now, it looks like I made a slight mistake somewhere with a sign, or minus sign doing somewhere. That's because this is minus 1, so this will be plus. This will be a plus, that'll be a plus, that'll be a plus. And there we go. So, very difficult question if you're not looking at the formula book. Hence, show that the integral of cosec 6 of x, cosec power 6 of x is equal to that value. So, this is going to tell us a relationship for all the different powers of 2. So, we're going to first need to work out what I of 2 is going to be. And we're just going to change our definition a little bit now. So, because we're defined as a definite integral. So, I'm going to redefine I2, so it's pi over 3 to pi over 2. That'll be cosec. So I'm just going to redefine actually. So I'm going to write in, redefine that as cosec to the nx dx. So that means I2 is going to be integral cosec squared, which is said to was minus cot. So that's going to be minus cot of x evaluated between those two values. So that's going to be cot pi over 3 minus cot pi over 2. And that we need to put in calculator. So we've got cot pi over 3 minus cot pi over 2. And that's going to give us 1 over root 3 or root 3 over 3. Now, it's going to be useful, we're going to have to work out what I4 is going to be. So, using our recurrence relation, it's going to be minus, so I'm using this bit here, I can just about see. That's going to be minus cosec squared of x times cot of x over n minus 1, so that'll be 3. That bit's going to be evaluated between the limits. Plus n minus 2, so that's going to be 2, n minus 1 is 3, times I2. So we'll have the I4 is going to be equal to this thing, which we'll work out in a minute, plus 2/3 times root 3 over 3. And now let's put this in the calculator. Normally these things are 0, but given the fact that this is 4 marks, I don't think it will be. So we're going to have minus cosec squared pi over 2 times cot pi over 2 over 3 minus, not going minus, so it will be plus cosec squared of pi over 3 times cot pi over 3 over 3. And that's going to give us 4 root 3 over 27. So let's just tidy that up a little bit before I work out the next one. So I've got 4 root 3 over 27 plus 2 root 3 over 9. So that'll be 6 root 3 over 27 times them both by 3. So that's going to be 10 root 3 over 27 for I4. Then to get I6, I have to do a similar thing. So we have now minus cosec to the power of 4 of x cot x is divided by m minus 1, so that's going to be divided by 5. Evaluate that between the limits. Then it was n minus 2 over n minus 1, so plus n minus 2 is 4, n minus 1 is 5, times the previous integral which we've just done, so that's going to be times 10 root 3 over 27. And we'll just have to hope to get the actual value. You can probably just put this in your full calculator and just get a number. That's probably not a problem. So minus cosec to 4 of pi over 2 times cot pi over 2 over 5. Minus same thing now, so plus cosec to the 4 pi over 3 times cot pi over 3 over 5. And that's going to give me 16 root 3 over 135. Sorry, my calculator just gives it unrationalised. Plus 40 root 3, and that's 135 quite nicely. So that gives us 56 root 3 over 135. Which is the same as like given, so I can rest in peace knowing that that has been done, and I don't need to worry about that when I'm looking back through the question.